We're here with Steve Hoover from PARC. I want to talk to you about some of what you talked about in your talk, which was 3D electronics. Is that how you would call it? The thin film?
Well, it's really
how would you describe that?
It's printed electronics.
Printed electronic.
We are at a change where computers have actually gotten smart enough and capable enough that they help us in making things. I think today we're very familiar, we hear a lot about 3D printing, which is a great thing. But what you can print is structures, mechanical parts. So we could print this chair, but we couldn't print that microphone, or my Bluetooth headset, or my phone. And the value of printing is two things. You can make in one place, without being an expert, very complicated shapes. So you don't have to assemble a whole factory or know how to go out and find a value chain and build it, a supply chain and all of those things. And the other is you can make them in quantity one. Right? I can make my chair designed for me to fit the way that I want it. Printed electronics is about the same things. How do I get small lots customized, and how do I get it right there when I need it, how I need it? The other thing it's about, though, is physical flexibility. So
you showed the example in a helmet, right?
Yeah, in a helmet.
Explain how that
Sure.
works.
It turns out that we see a lot of soldiers coming back from overseas who have sustained brain damage from low-level repeated exposure to explosions. So a blast dosimeter is like a radiation dosimeter in the sense of it measures and integrates over time the blasts you've been exposed to. And so this was a sensor tape that we did the fundamental technology for to prove that you could print the electronics, the circuits, the transistors, the sensors, the pressure sensor, the light sensor, temperature sensor, the battery, and put it on a soldier's helmet. And so in that case, the real benefit is the conformability, the flexibility, right? And printing is low cost. So how can I print this and again put it on every helmet, and when it, you know, the blast dosimeter has a life of whatever, over 2 weeks, it measures those, you rip it off, you put a new one on.
And it's printed right on the tape, right?
Printed right on the tape. So again, printed electronics allows you to print on flexible things. We could print electronics in your suit. We could print the microphone in your lapel so that it was just there.
And in theory, this could be done remotely in various different remote regions.
Yeah, so you can give a device, again, the idea of 3D printing, it's again, you don't have to have a supply chain. It is the supply chain. What we do is we do that very early stage, the science, and then the innovation around that science to create an offering, and then we work with a commercial partner who they really take the product to market. And we're even doing printed energy. We've been investing ourselves to the point where we showed some capabilities to print batteries. And it turns out that battery manufacturers are focusing a lot on chemistry, not the manufacturing process, not the fine structures. We can do this at very low cost and get perhaps a 20 to 25% improvement in cost and storage density of a battery.
So that can have a huge impact on the manufacturing, the cost, the end product, whether it's a car or electronics, things like that.
Could be your cell phone, make those iPhones last a little longer before we have to find a charger for them.
How do you decide what you're going to work on?
So we're just out there investing in these areas at a relatively low level because they're fast changing areas of technology. That's where you make kind of a lot of small bets. When you're making the big bets, what you try to do is find an area where there's a big problem that if you made a big difference, people are likely to pay money for. That may turn into opportunities for Xerox. Some of it never will. But what it does is it keeps a good, vibrant research base for Xerox to draw on. And what we do is then we create new areas independent of whether Xerox is the best place or not, and we just find the best place in the world for it.
Right, so you have a lot of different kind of partners.
And then we make profit. Again, when I go out and I license this battery technology to a partner, I'm going to make a profit on that. So Xerox doesn't tell us what fundamental research to do. We decide ourselves and reinvest our own profits.
One thing I want to ask you about is hiring. How do you bring in the best talent, given all the competition these days?
We compete with Google and Facebook and Amazon. Our environment is if you've got a good idea, and we do some investment to kickstart it, if you can find government funding, if you can find a commercial partner to keep it going, if you can find a startup, and actually by the way, about 25% of our commercial clients are startups, both around the world and in the Valley, then you can do that work. So that freedom, right, which is more like an academic environment where you're able to take your interests where you want. But unlike an academic environment, what we're about, the people we attract, they want to build things that people use. You know, in the end, you want to do the fundamental science, not just research for research's sake, but research to create an impact in the world.